Good evening. Welcome to Sriveda IT. This is DS Prasad. Today we are going to discuss about the most important topic from the recursion. That is the 11th topic. What is call stack or stack memory? So what is call stack or stack memory from recursion that we are going to discuss today? Sir, Python. So Python maintains a memory structure. Python maintains a memory structure called call stack or stack memory. Or stack memory. So Python maintains a memory structure called call stack or stack memory. A call stack or stack memory is a data structure. So data structure that stores what it is going to do. It stores information. It stores information about 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 every active function call. So every active function call. So what exactly this means? So Python maintains a memory structure that is called call stack or stack memory. And call stack or stack memory is a data structure that stores information about every active function call. Okay. So let's see that. We are going to discuss with an example. Let's write any one recursive function here. Def recursion is a function name and taking the parameter n. If n is equals to 0, not 0, 1, so which is the base condition, so return 1. Okay, so return 1. After that, we are going to use the recursion and we are going to change in the parameter by reducing the 1 and we are going to print that work. And after that, so what is going to happen means we are going to call that recursion function and we are passing the value n. Here n is equals to something int of input like that we are taking. Okay, so this is good. What exactly meaning of this? Means if you take that n is equals to 5. So what will happen means, so this is recursion function, right? I'm going to consider that recursion of 5. And is n is equals to 1? No. And it will back to here. So it will come to here and then it will call that recursion 4. Again, recursion 4 go here. Is 4 is equals to 1? No. And again it will comes to that recursion and recursion 3. Again, so recursion 3, before printing, again it will go here and it will check that. Okay. Again, recursion 2. Similarly, recursion 1. Whenever it reaches that 1 is equals to 1, return 1. Okay. Meaning, so for recursion 5, we will get the 5. For recursion 4, we are going to get the 4. For recursion 3, we are getting the 3 and 2 and then 1. So printing, in what way it is printing? From top to bottom. Okay. But this is just our procedure. But top to bottom in the sense means what? So like output will be in the form of, so like 1, 2, 3, 4, and then 5 because it is a head recursion. Head recursion. Okay. So we'll discuss about head recursion and tail recursion in the later section. But what I am going to specify here means, so as I said that it is going to store every function call, active function call. So what is the function call here? Recursion 5 is a function call and 5 is the output variable. And recursion 4 is also a function call and 4 is the output variable. It is going to store this function calls and variables inside the memory. Sir, how this memory is going to be? I will show you that one diagram. So here, so we are going to have this kind of memory will be there. Okay. This is nothing but called as a call stack. So this is nothing but call stack. And here, so when we call the function call here, so recursion 5 we are going to get. And after that, here recursion 4 is going to be stored. And after that, recursion 3. And after that, recursion 2. And after that, recursion 1. And then, so we also can take a recursion 0. And it is a base case. There we are going to return. So where we are going to return. And output. So this is called nothing but top. And this is nothing but called bottom. Okay. So what we are doing here means we are pushing that operation. Push. and then push, and then push. Okay. After this pushing, we are getting the outputs in the form of 1, 2, 3, 4, and then 5. What is going to happen means here it is going to pop, and it is going to pop and bring give the result. Okay. And this is going to pop and get the output. This is going to pop, and this is going to get the output, and this is going to pop. And here, this is nothing but called bottom, and this each row is there, right? In this this one is called stack frame. This is called stack frame. For each function call, stack frame will be created. Each function call. So each function call stack frame is created. And this is called call stack or stack memory. So call stack or stack memory. So remember that one, call stack or stack memory. Okay. Sir, every function call. So here, every function call. So creates a stack frame. So stack frame, we'll discuss that stack frame also, what exactly means. And variables are stored in that frame. Not only variables, we are going to store the function calls also inside that frame. Okay. Frames are removed. So frames are removed in last in first out order. First out order, last in, first out order. Sir, that is what exactly I discussed here. See, frames. So what are those frames here? So here, this is. So last in, okay, first out. Last in, first out. First, recursion 5 is stored inside this stack frame. And recursion 4 inside the stack frame, and recursion 3 inside the stack frame, recursion 2 inside the stack frame. This storing is nothing but called push operation, and while getting the output is nothing but called as a pop operation. Okay. So recursion 1, this is a last in, so last in, first out, so last in, first out. Okay. But for any recursion, any kind of recursion, means any type of recursion. For any type of recursion, this call stack is same. Call stack is same. Call stack is same, meaning this stack memory looks like this only. But the representation of output. So how we are going to get that output? So that is more important. From top to bottom approach or bottom to top approach. In which order you are going to get, that is decided by the work and recursive function. Work and then so recursive call. So work and recursive call. So here these two are more important. Work in the sense means print that output. So print n. Recursion call means recursive, so recursion of n. So these two decides if one upon the other or one below the other, which decides the output. But the stack memory or call stack is looks like this only. I have a diagram also, so that we will see that one. Okay. So frames are stored in last in, first out. Okay. Removed in. So call stack, stack memory, stack pushing means placing function 3. Stack means pop. So displaying the results like 4, 3, 2, 1 or 1, 2, 3, 4. So this is completely called as call stack or stack memory. And initially this main is nothing but address bar. And here function 4, function 3, function 2, function 1, function 0, and then main. Okay. So removed in the last in first order. This is a stack frame for each function, store variables. Frames are removed in last in first order. And this is nothing but called as a bottom up approach. Okay. So here this is called as bottom up approach. Okay. Bottom or top down approach. This is the base condition. So this is nothing but called as um, call stack. And how it is going to work means, example, if you take any example, here we are going to first push that function, push, and another one push. 3 functions completed, like function 3, function 2, function 1. After that, we are going to pop that one, pop, pop, and then pop, because 3 functions, 3 pop operations. How many push operations? Those many pop operations. Okay, we have a dedicated session for push and pop operation also. We'll discuss that in the next section. Okay, so thank you.